Hi everyone, welcome to Lecture 19, Association Rule Models. Now, what are these models used for? A data instance typically has one or more features. For example, consider you have a customer. This customer could have features such as age, gender, income level, history of past purchases, all those things. Or consider a smart meter. A smart meter could be a data instance, and the data that it provides could have different features such as the voltage at that particular point in time, the current, the active power, the reactive power, power factor, all those values. Now, if these features are continuous, obviously we can use correlation to determine whether there are patterns between them. But if there are non-continuous features, we're not going to be able to use correlation. So association rules allow us to detect existing patterns between non-continuous features of data instances. Let's think about some examples. When you go shopping, you are one data instance, and then all the items within your shopping cart, these would be the different features associated to you. So for example, one question that I might have if I'm owner of a store would be, what products are usually purchased together? Or for example, what credit card offers typically customers with the same credit score apply for example? Or people who are customers of an insurance company, what types of different insurance policies do they typically purchase together? Or if you are a visitor to a particular website, for instance, what types of advertisements do you click on usually? So these are different patterns between non-continuous features that we would like to explore. Typically, the idea behind this is to have more targeted advertisements, or for example, make suggestions to different customers. For example, when you go surf on Amazon to find a book and you pick your book, and then Amazon gives you certain recommendations that people who bought this book also bought such and such. This is essentially their way of looking at correlations between these non-continuous features. So they look at individual customers as data instances, and then they look at what features they have, what books did they purchase, and then they try to figure out whether there are any patterns there so that they can make recommendation to you. All right, so what we do is to mathematically model this, we look at a data instance as a set of features. So a data instance here that I'm showing it as data instance, let me use this, so data instance D, we assign an identifier to this, which is going to be I of D, and then this particular data instance is going to have features. These features are categorical data points, are non-continuous data points. So we'll look at them as a set of items, and this is known as an item set. Some examples. This data instance could be a customer, and then the item set would be all the different items that he or she has in the shopping basket. Or for example, could be an Amazon customer, and the item set would be all the books that this person has purchased in one transaction. Or it could be a visitor to a website, and the items set would be the different advertisements that this person has clicked on. Or like I mentioned in the previous slide, a customer to an insurance company or to a bank, and the item set would be the number of different policies that this person has with the insurance company, or the different types of accounts that he or she holds with the bank. So this would be an example of an item set. Now, for an item set, we can define an association. Association in general is an implication of the form X, then Y, where both X and Y belong to the item set and they do not overlap. So the intersection between X and Y would be 0. Some examples of this. For instance, a customer who buys apples, in 75% of the cases, also buys bananas. So we have some sort of an implication, apple, then banana. Or for example, customers who buy the book Big Data World also buy the book What is Smart Grid? So there is an implication here, Big Data World, then what is Smart Grid? So this allows us to create some sort of an association between these different items that exist in the item set. Now, the one thing that you have to remember about these rules, about these implications of the form X then Y, is that this just indicates chance, likelihood. There is no guarantee. If we have a rule of the form apples then bananas, there is absolutely no guarantee that the person who buys apples also will buy bananas. It's just a chance. There is a chance 40%, 50%, 80% that the person who buys apples will also buy bananas. Also, keep in mind that just like we talked about in correlation, this is a measure of association. I'm associating X and Y together. This is not causation. In that example of a customer who buys apples also buys bananas, this is not a causation. So the customer does not buy bananas because he or she has bought apples. It's just an association between apples and bananas. Now, one metric that we can define for either item sets or for rules is support. Support for an item set is defined as the percentage of the total data instances that contain that particular item set. So imagine I have an item set IFD. Support for that IFD would be the number of instances that contain it divided by the total number of instances. We can extend this to a particular rule as well. So if I have a rule of the form X then Y, support for that rule would be the number of instances that contain both X and Y divided by the total number of instances. Typically what we do is we define a minimum support as a threshold. We call this min sup. So if a particular item set has a support which is greater than min sup, we then call that particular data set, item set, a frequent item set. Okay, let's practice this through an example. Imagine we have this data set that we have obtained from a grocery store. So there are 10 data instances, let's say each one representing a customer, along with the items associated with each one. So the items would be the items that this particular customer has purchased. What I would like you to do is to find a support for this rule, apples and bananas, then milk. At this point, what I'd like you to do is to pause the video, go through this exercise. When you're ready, hit play to see the answer. Okay, so when we go through this particular example, see that my rule is of the form X and Y, then Z. One thing important that you have to keep in mind is when I'm looking at a general rule of the form X then Y and I want to calculate the support is defined as the number of data instances that have both X and Y in them divided by the total number of data instances. Notice that in doing so, I'm not distinguishing between X and Y. So the support for the rule X then Y would really be the same as the support for the rule Y then X. There is no difference because all I'm doing is I'm looking at the number of data instances that have both X and Y. So in this case, I'm looking at the number of data instances that have both X, Y, and Z, so all three. So apples and bananas, I only have apples for the first one. For the second one, I don't have any of them. I have apples and bananas and milk for customer number 3. Then bread, chocolate, chips, and coffee, milk, water, apples, and bananas, so number 5 as well. Number 6 doesn't have all of them, 7 doesn't have all of them, and then number 8 has all 3. Number 9 and 10 do not have all 3. So 3 out of the 10 total customers have apples, bananas, and milk. So the support for this would be basically 3 out of 10 or 30%. So this rule, apples and bananas, then milk, has 30% support based on this data set that we have. Again, I'd like to emphasize, keep in mind that this rule indicates association. This is not causation. So this rule is not trying to assess whether people buy milk because they have bought apples and bananas. It has nothing to do with causation. It's just a matter of association. Another metric that we define for the rules is confidence. Confidence for a particular rule, X then Y, is defined as probability of Y given X. If we translate this in the form of support, confidence would be support for X then Y divided by support for X. If every item set that has X also has Y, that means support for X would be the same as support for X then Y, meaning that confidence would be 100%, meaning that we know that if somebody buys X, for example, this is the example of grocery store, if someone buys item X, they will definitely buy item Y. So this would be a confidence of 100%. Similar to support, for which we defined a threshold of min sub, we also have a min confidence threshold for this particular metric. All right, second exercise. So again, for the same data set that we saw in the previous activity, what I would like you to do is to identify how confident we are in the rule that we talked about, apples and bananas, then milk. So at this point, again, please pause the video, go through this exercise. When you're ready, hit play. All right, apples and bananas, then milk. So confidence for apples and bananas, then milk would be equal to the support for apples and bananas, then milk, divided by support for apples and bananas. Remember, support for X, then Y, divided by support for X. So here, this will be my X, this will be my Y. If I do the analysis, I know that support for apples, bananas, and milk from the previous exercise, I know that that is 30%. If I want to calculate support for X, so how many of these customers have apples and bananas? Here, I don't care about milk anymore. If you do the analysis, you will see that 4 out of 10 customers have both apples and bananas. So now the confidence will be support for X, then Y, which is 30% or 0.3, divided by support for X, which is 40% or 0.4. So we have 75% confidence in this rule that we have defined, apples and bananas, then milk. So if someone purchases apples and bananas, we are 75% confident that he or she will also purchase milk. A third metric that we define is lift. Lift is also referred to as the interestingness measure. Basically, lift is defined for a particular rule, X then Y, as support for X and Y divided by support of X times support of Y. If lift is 1, that means the support for X and Y is entirely defined by the marginal support for X and marginal support for Y. That means there is really not a meaningful interaction between X and Y. When lift is less than 1, that means that there's actually a negative dependence between X and Y. And if lift is greater than 1, that means the dependence between X and Y is positive. Let's see this through an example. Okay, so imagine we have this data set that is obtained from a grocery store out of a total of 1,000 customers. We have looked into people who have bought both tea and coffee, or one of them, or neither one of them. And we have listed them in this table. What we're interested in is this particular rule, tea, then coffee. And what I would like you to do is to calculate the support, the confidence, and lift for this rule and compare the results. So again, please pause the video, work through this exercise, and when you're ready, hit play. All right, so the rule is of the form X then Y. Support for tea then coffee would be the number of instances that have both tea and coffee in them divided by the total number of data instances. People who have both tea and coffee are 150 customers. So 150 divided by 1,000 would be 15%. Now, if I look at the confidence in the rule tea then coffee, confidence would be 150, which is the support for X then Y, divided by support for X, in this case for tea. How many people have purchased tea? 200 out of a total of 1,000. So 150 divided by 200, which is 0.75 or 75%. Finally, when I calculate the lift for tea then coffee, that would be the support for tea then coffee divided by support for tea times support for coffee. From the first example, this support for tea then coffee would be 0.15 or 15%. The marginal support for tea would be 200 people or 0.2, and marginal support for coffee would be 900 people, or 0.9. This lift would be 0.833, which is less than 1. Based on what we saw in the previous slide, when the lift is less than 1, that means there's actually a negative dependence between tea and coffee. But let's dig a little bit deeper here. Take a look at the confidence. The confidence I have in the rule, tea then coffee, is 75%. That's a pretty high confidence. But let's look at the prior probability of people buying coffee. In general, 90% of people, 900 out of a total of 1,000, 90% of people are actually likely to buy coffee. Whereas when I look at tea then coffee, the number goes down to 75%. What does that mean for us? That means that people who actually buy tea are less likely to buy coffee than general, because in general, 90% of people will buy coffee. So that means that there is a negative dependence between tea and coffee. If somebody buys tea, less likely to buy coffee, and the other way around. And this is indicated in lift. Lift is less than 1, indicating a negative dependence between X and Y, tea and coffee in this example. Now, this, of course, was a very small sample space. We didn't have a lot of dimensions. We didn't have a lot of data instances. But in general, you have to come up with an automatic way to be able to create some rules. So the general approach that we have is as follows. First, you have to, as a data scientist, you have to specify what your minimum support and minimum confidence thresholds are going to be. This basically determines above what levels you consider things to be interesting. Because, for example, if your minimum support is 30%, that means if a particular item set appears in 30% of your data instances, you consider that frequent. Maybe somebody says, no, I would like this to be more than 70% of my data instances. In that case, I would call it a frequent item set. This is up to you. So this is something that you have to decide on as a data scientist. What you do then is you will look into all the different possible item sets, and then you identify those that are frequent, meaning that those particular item sets that have a support greater than minimum support. For each of those item sets, you generate some subsets. We call them K. These subsets have to be non-empty. And then for each non-empty subset of that particular K, you will generate rules of the form S then K minus S. If that item set has apples and bananas and milk, for example, your rule could be apple, then banana and milk. Milk, then apple and banana. Banana, then apple and milk. Apple and banana, then milk. So you can have multiple different variations of these. And then you calculate confidence for each rule, and you keep the ones that have a confidence greater than the threshold that you have defined. These will be the rules that are both interesting and at the same time you are confident in them. This is likely to give you a large number of rules, and keep in mind that when you have too many rules, interpretability is going to be problematic. You're not going to be able to look at them and identify interesting patterns. So there are some additional kind of rules of thumb to help you narrow it down. One would be, for example, you can remove the rules that have obvious patterns, something that is not too informative for you. For example, look at an example of a group of customers that are doing grocery shopping at a supermarket. Typically, when someone buys pasta, they will also buy pasta sauce, right? So a rule of the form pasta then pasta sauce is probably not that interesting or not that important. Or for example, if someone buys a birthday cake, it's very likely that they purchase birthday candles anyway. So a rule of the form birthday cake then birthday candles, that again is something which is obvious and it's not of too much interest for you. Another thing you can do is, because your min sub and min confidence thresholds have been determined based on like expert judgment, and there is really no mathematical rule behind it. What you can do is you can play with them, raise them, lower them through a sensitivity analysis, and see, for example, you lower your threshold if you get more interesting rules, if you raise your threshold, for example, if you lose some interesting rules. So play with that until it gives you a certain set of rules that you feel comfortable with. And of course, you look at the lift measure to identify whether there are any positive dependencies or negative dependencies between items that are in a particular item set. Now, we're going to do this in this activity. So for that activity 1 and 2, in which we looked at the list of uh, data instances being the customers and the items that they have purchased at the supermarket, what I would like you to do is consider this item set apples, bananas, and milk, and essentially find all the possible association rules for which the confidence is greater than 50%. So you will come up with all the possible rules first, then you calculate the confidence for each one and only keep the ones in which you are 50% or more confident. Again, pause the video at this point, go through this exercise, and once you're ready, hit play so I show you the answer. All right, so assuming you have done these different combinations of rules that you can be obtained from this item set, these are the series of rules that you will get with a confidence of higher than 50%. Okay, so this brings us to the end of this lecture. To have a recap, we talked about association rule models. This is a technique that allows us to identify underlying patterns between the non-continuous features of data instances. As I mentioned in the beginning of this lecture, if you have data instances with continuous features, you can always use correlation, and that will show you if there are any interesting patterns between those features. When they are non-continuous, correlation is not going to work. And what we do is we develop rules that indicate whether various features are associated with one another.